Where's the gray that I needed the most? I pick up a pencil and the knowledge is lost. They tell me my grades are slipping away. They tell me it's hurting my GPA. And I don't need no tutor, Mom. 'Cause I had a bad test, I'm failing it now. I do the retake just to turn it around. Just kidding, there are no retakes in calculus. You say I don't know, maybe you're right. I fake up a smile and pretend I'm alright. I had a bad test, the plunkett don't lie. My chances for credit are going awry. I had a bad test. I had a bad test.
The point is to optimize what they say, and I'm here to help you learn. So this guy, he had a bad day, the kids broke his glass, Jimmy hit it too hard and that window was smashed. He needs a new frame, but he doesn't know how to optimize the area of a Norman window.
A Norman window is constructed by adjoining a semicircle to the top of an ordinary rectangular window. Find the dimensions of a Norman window of maximum area if the total perimeter is 16 feet. To begin, a Norman window looks like this. It is a rectangle conjoined with a semicircle. The radius is going to be half of this length right here. So this length can be x, and then the radius is going to be x over 2 for the radius of the semicircle. And then we're going to also have length of this side of the rectangle here, which is y. So we begin with our primary equation, which is going to be the area. The area is going to be both the combination of the area of the rectangle and then the area of the semicircle. So the area of the rectangle is just going to be x times y, and then we have the area of our semicircle. Now if you recall, the area of a regular circle is pi r squared. However, since this is only half a circle, we're going to have to divide that in half. So it's going to be pi over 2 times x over 2, which is the radius, squared. So we then have a secondary equation. The secondary equation is going to be the perimeter which was given to us, which is 16 feet, equals 2y, which is two sides here, 2y, plus x, plus pi times x over 2. Now this part that's pi times x over 2 comes from the perimeter of a semicircle. The perimeter of a regular circle is 2 pi r. However, we must divide that in half for a semicircle, so it's just going to be pi times the radius, x over 2. So what we then do is we want to get rid of this fraction right here. So what we then do is we multiply everything by 2 in the problem. So it's going to end up equaling 32 equals 4y plus 2x plus pi x. So we then want to solve for y or x, it doesn't really matter, but we need to plug whatever we solve for back in for the area equation. So here we solve for y. So y is going to equal 32 minus 2x minus pi x over 4. We then plugged in what we solved for y back into the area equation for y, so then we only are going to have x's in what we have. So it's going to equal x times, for y, 32 minus 2x minus pi x over 4, plus pi over 2, x over 2 squared. So then what we actually do is we just simplified this a little bit further to get pi x over 2 over 8. And then what we do is we pretty much FOIL this all out to get 8x minus 1/2 x squared minus pi over 4x squared plus pi over 8x squared, and we derive. The derivative is necessary in order to find the dimensions in order to maximize the area. So the derivative is going to be 8 minus x minus pi over 2x plus pi over 4x. And now what we do is we just combine these two values and factor it in order to make this a little bit simpler, which is 8 minus x times the quantity 1 plus pi over 4 equals 0. We have to set it equal to 0 in order to find maximum. We first get that x equals 8 over 1 plus pi over 4, and we simplified that to equal 32 over pi over 4. And we just wanted to make sure that this is in fact maximum, so we created a number line and we plugged this in for the derivative and found that it was positive and then negative, which will give us our maximum. So now that we have found x, we must also find y. So what we do is we take x and we plug it back in for the equation at the top in which we solved for y. So that is going to equal y equals 32 minus 2 times the quantity 32 over x 4 plus pi minus pi times the quantity 32 over 4 plus pi. And remember that 32 over 4 plus pi is what we got for x, and that's what we're plugging in for that equation. So what I did here is I just simplified this further and went 32 minus 2 and distributed the 2 here, distributed the pi there. So 32 minus 64 over 4 plus pi minus 32 pi over 4 plus pi times 1/4, which is the same as dividing by 4 here. And then I went to find the common denominator of 4 plus pi. These two values already had the 4 plus pi, but we had to give it to also the 32. So 32 times the quantity 4 plus pi minus 64 minus 32 pi over 4 plus pi times the 1/4. And then if you continue to simplify by factoring in the 32 here in this quantity, what will end up happening is there's going to be a 32 pi and then a negative 32 pi that can cancel, and then we have a 128 and a negative 64 all over 16 plus 4 pi because I factored in the 1/4 here. So what we end up having once we combine everything is 64 over 16 plus 4 pi, and then we divide everything here by 4 since they're all 4 can go into everything here. It's going to equal 16 over 4 plus pi. So this is our y and this is our x, and these are the dimensions that will maximize the area of the Norman window, which is 32 over 4 plus pi by 16 over 4 plus pi.
This other guy, he had a bad day, his fence was torn down, the cows are now free and they're running around. To keep them contained, he's bought some supplies, he's got a new fence, he's got to maximize.
So the problem is asking us to maximize the area of fencing. So we're going to need both a primary and secondary equation. The primary equation is for the area in which we have to maximize, which was going to equal A equals x times y. Our secondary equation is going to be the dimensions they give us, which is going to be 8 equals 2x plus 4y. We're using two different variables because we have two different lengths going on. We have two x's, which is going to be here and here, and then we're going to have 4 y's, which is these 4 lines right here. Now what we do is we are isolating the x by solving for it, and what we did was we subtracted the 4y, and then we end up getting that x equals 4 minus 2y. What we do with that is that we then plug this here back into this equation. So we are only going to have one variable to solve for. So what we do is we then distribute the y. So then the area will equal 4y minus 2y squared. What we then do is we derive, and we get 4 minus 4y. So y ends up being 1, and in order to solve for x for the dimensions after that is we plug this 1 back in for this equation in which we solve for x. And then we will get x equals 2. So that will give us 2 by 1 meters.
Sometimes when you work real hard, then the whole thing turns around. And soon it stops looking like the problems are written upside down. No more frown. Yeah, 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 yeah. There was the gray that I needed the most. Oh, I squared pi. I picked a BA and the GPA's up. 'Cause I had a great test. I'm passing count now. On the top of my paper, Mrs. Plunket said, wow, optimization I know, I cannot deny. It wasn't so hard once I gave it a try. I had a great test, I got a few right, and how